Calculate the ratio of rates of diffusion of U35 UF6 and U38 UF6. So two isotopes of uranium fluoride has been given, and we have to calculate their rates of diffusion. So again, by using the formula, radius of the UF6 235, rate of diffusion of UF6 divided by rate of diffusion of UF6 238. Okay, so we'll take the, as we know, this is inversely proportional to the square of their molecular masses, so we can put directly here a value molecular mass of UF6 235, and here again molecular mass of UF6 238. So we'll get here molecular mass, already we know that. So if you divide it here, that is molecular UF6, so fluorine is 17. So if you multiply this one, so you will get here 6 fluorine is there. So again we'll get here mass 249. So molar mass of U is 235 and 6 into 17. So we'll calculate here. Similarly we'll calculate here. So this will come here 352, because there 5 is there, here 8 is there, so it will be, so again if you divide it, so you will get here 1.00413. so this is the rate of diffusion of these two gases, two molecular radioactive isotopes. So we can calculate their ratio also. So now next problem. A gaseous mixture containing the helium, methane and sulfur dioxide was allowed to diffuse through a fine hole. Then find what molar ratio of gases coming out initially. If mixture contains these three gases in the ratio 1:3, mole ratio they have given it. So we can take here moles of helium divided by moles of methane. So we'll get here ratio 1:2 is given, so 1/2 square root of, so methane is here molar mass, helium is 4, so here we get ratio 4 is 4, so 2:2, so 1:1 ratio will get here. Similarly we will find helium and sulfur dioxide, moles of here helium divided by sulfur dioxide. So we will get here again their ratio is 1:3, so 1/3, and here square root of sulfur dioxide is 64 under by 4. So if you solve it, you will get here 4/3. So ratio of helium means helium, similarly methane is to NSO4, so it is come 1:1, so it will be your 1:1:, so this is coming here 4/3. So 4 means helium, moles of helium and methane is same, so it will be here 4, 4 and 3. So this is the ratio of these three gases present in the mixture. So now next problem. So here next problem is 80 ml of oxygen takes 2 minutes to pass through a hole. So what volume of sulfur dioxide will pass through the hole in 3 minutes? Okay, so we can see problems. So again see here two gases there, so rate of, we can find a rate R1 by R2, this is equal to V1 by T1, diffusion volume of gas diffused by time taken, volume of gas diffused by time to taken is inversely proportional to square root of m2 by m1. So again what volume they ask, volume is given or volume is asking or time is asking, so we can modify to write here volume 80 by, so we can here 80 by 2 into, so again here 3 by V2, and molar mass we know that is molar mass of sulfur dioxide is 64 and that of oxygen is 2. So if you divide it, it is 2 root 3 2, so again here 40, so V2 will be 120 divided by root 2. So this is the answer of this one. So now next is 4 gram of sulfur dioxide diffused through a container in 8 minutes. So mass given, what is the mass of helium gas diffusing from the same container over the same time interval? So time interval is the same, and we can see here same container, time is same here, and the weight they have given, time they have given 8 minutes same. So helium and 2 gases are there. So we can see, so we can write here volume of gas diffused by time taken. That is, we know that square root of density of the gas. So we can do it right here, molar mass. So volume gas diffused means V1 by T1 is 1 by root m, and V1 is proportional to number of moles. So we can write here moles by time taken is 1 by root m. So we can take two values are there. So we can write here N1, 2 gases there, so N of SO2 divided by N of helium, and time, since time is same, time for each is same. Helium for we can take moles only, so is equal to 1 by molar mass. So molar mass of sulfur dioxide and molar mass of helium. So this will be square root. So again, if we solve it, this here solve it. So weight of sulfur dioxide is 4 by 64, and weight of helium, weight they are asking. So right here, weight of helium divided by 4 is equal to, this will be your weight of helium 4, and this is 64. So again, this will come out. So this will be your 1 by 16, 4. So this will come 4 by 64. So this will come as 4 upon weight of the helium. Okay, this is the weight of the helium multiplied by 4 into 64. This is equal to square root of 1 by 16. So 4 is there. So again, if you solve it, so it will come here. So weight of the helium. So this will be your 16, 4, and this will be 1 by 4. So weight of the helium will be 1 gram. So this is the weight of the helium. So under identical conditions of pressure, temperature, 4 liter of gaseous mixtures like hydrogen and methane diffuses through a hole in 5 minutes, whereas 4 liter of a gas X of molecular mass 36 takes to 20 minutes to diffuse through the same hole. So what is the mole ratio of hydrogen and methane in the mixture? So pressure, temperatures are constant, and volume they have been 4 liters. 4 liters, 5 minutes, and again volume is same. X is 36, it takes molecular mass 36, it takes 10 minutes. So same formula. So we can use here rate of the mixture, because 2 mixtures is there. The rate of the mixture divided by the rate of the X gas. Okay, so they have given here. Okay, so time, volume the gas. So this is the volume the gas diffused. So volume the gas is 4 divided by 5 minutes, and volume of the X is 4 divided by 10 minutes. Okay, and that is equal to molar mass of the X divided by the molar mass of the mixture. So we can see here, this will be your 2, and molar mass of the X, that is 36 they have given. So right here 36 divided by molar mass of the mixture is this one. So on solving this, we will get 6. So it will be 4. So molar mass of the mixture will be 4. So 4 by, no, it will be your 4. So it will be your 36 by 4. So you will get here 9. So 9 is the answer. One more thing, 9 answer is still there. molar mass 9 is there now. So we have to find the mole ratio of hydrogen and methane in the mixture. So 1 is left out. So mass of the mixture is moles of gas hydrogen into molar mass of the H2 plus moles of the methane is to molar mass of the methane. Okay, so here moles we know that is 9, and here hydrogen we don't know, so we can write here moles of the hydrogen 2 into x of hydrogen and plus 16. So mole fraction of these two cases is 1 minus x of hydrogen. So on solving we will get here mole fraction of hydrogen will be how much? On solving this will be your 0.5. Okay, then moles of the methane will be your how much? 0.5. So ratio will be mole ratio will be 1:1. So this is the final answer. So I have done previously a wrong answer, so just this is the answer actually. Now this questions. A certain gas diffuses from two different vessels A and B. A certain gas which diffuses from two vessels A and B, and the vessels has a circular orifice while vessel B has a square orifice of length equal to the radius of the orifice of vessel A. What is the ratio of the rates of diffusion of the gas from vessel A to vessel B, assuming temperature and same temperature and pressure? So again we can say moles of diffused gas, moles of gas diffuses, okay, through from vessel A. So vessel A has a circular orifice, so from vessel A, okay, so it will be how much? And surface A, and whose surface area? Surface area they have given. Suppose you want circular radius, so you take the radius. If you take the radius, it will be your pi r square, where r is the radius of orifice. Now similarly, moles of the gas diffused from vessel B. So vessel B whose surface area, so they have a radius of the orifice of vessel. This is the square. So they have given this is a square shape. This is a square. So a square will be, and the length of the orifice is r square. Okay. So now we know that rate of the 1 by rate of 2 is equal to square. So here molar mass of 2 by molar mass of 1. This is as per the Graham's law. Okay. Pressure, temperature remains constant. So what happens here? So molar mass is there. So since this is equal, so we can see here R1 is equal to R2. Okay, R1 is equal to R2. So R1 is nothing but the volume of gas diffused divided by time taken. Here the volume of the gas diffused for A1. This is B1 divided by time 2. Since time is equal, so volume gas remains. So volume of the gas, so this is the R1, this is the R2. So we can see here R1 by RA by RB. So RA, so volume nothing but the pi r square into area into length. Area into length. So area is how much? So area is here for square. So area is for square is not square, for circle. For circle is pi r square, and for a square is how much? So for a square is your r square. So this r square cancel. So radius of A by radius of B is equal to pi. So this will be your rate of diffusion of the gas from vessel A to vessel B, assuming the temperature and pressure constant.